Hello, welcome to section 6.4 from our trigonometry course, and I'm going to do my best to give a brief overview of this entire section. I've already got a lot of the notes laid out. Let's go through the notes, okay? So the first thing that I want to point out is that this section is graphing the sine and cosine functions. So what I've done is I've written the general form of both the sine and the cosine function. And I'm going to specify here at the beginning that these problems in this section, we're not going to have what's called a vertical shift, and we're also not going to have a phase shift. So we're not going to have to worry about either one of those concepts in this section. Those will come later. So if you notice, for both sine and cosine, we have variables. The variable a is the lead coefficient of the trig function, and the variable b is the coefficient of the angle, the coefficient of x in the angle. And so down here we have what's called the amplitude. In order to find the amplitude, you're going to take the absolute value of a. So taking the absolute value of the lead coefficient is going to give you the amplitude of the function. The period formula for both sine and cosine, and I'll go ahead and mention at this point for both secant and cosecant as well, the period formula is 2 pi divided by b. And b, again, is the coefficient of x. That's from the angle. So the period is going to be 2 pi over b, whatever that number happens to be. All right, and for later reference, I'm going to be using lowercase a to designate amplitude and capital T for period, just to make it easier for me. The domain and range for both of these functions actually never changes. The domain is always all real numbers, negative infinity to infinity. And the range is going to be negative amplitude to positive amplitude. So you're going to take the absolute value of A to get your amplitude, and then the range is always going to be negative, whatever that number is, to whatever the number was, okay? And again, this range is going to work as long as there's no vertical shift, which I said we don't have to worry about in this section, okay? Now then, as far as the graphing process goes, we have a 6-step method for graphing. And the first step is to locate the starting point. Now, the starting point is going to depend on your trig function. So if you're doing a sine function, the starting point is going to be at the origin. Sine starts at the origin. If you have a cosine function, that's going to start at A, whatever the value of A was, not the amplitude, but the original value of A. And notice that both of these do start on the y-axis. So those starting points, either the origin or A, is going to be on the y-axis. And then once you locate the starting point, the next step is to deal with the phase shift. Now, I said in this section we're not going to have a phase shift, so we can ignore that part of the process in this section. Later, that'll become important. Third step is to figure out the wavelength, and that is the period. So whatever we calculate the period to be, that's going to be our wavelength. That's going to be the distance that it takes to complete one cycle, okay? One period. Step number 4 spaces, and that means what it says. It means from start to finish, you have to have 4 equal spaces. And the reason for that is because when you lay out your spaces, the hash marks are where your points go. So then you can lay out your points, and step number 6 would be connect the dots. Now that is the process. What we're going to do now is we're going to demonstrate all of this that I've talked about, and we're going to do it through 3 examples, okay? So example number 1, we have y equals 2 sine of x. And the first thing we're going to do is we're going to figure out the amplitude, okay? So remember, the amplitude is the absolute value of A. Absolute value of 2 is 2. The period is 2 pi over B. Now, you can write it as a fraction, or you can say divided by. Since I'm limited on space, I'm going to say 2 pi divided by whatever B is. B is the coefficient of x, and so in this case, B would be 1. Anything divided by 1 is itself. So now we know the amplitude and the period, and that should be enough information to go and produce the graph. Remember, I said later in other sections, we're going to find what's called a phase shift and possibly a vertical shift and deal with those, but that's not part of this lesson. All right, so here we go. In order to graph this wave, if we go back to our graphing process, it says first we have to figure out the starting point. In this particular example, we do have a sine function, and that means that our graph is going to start at the origin. So we're going to put a dot at the origin. Step number 1. Step number 2, phase shift, which we don't have one. Step number 3, wavelength. So our period this time is 2 pi. And so that means I'm going to come out here some distance and call that 2 pi. And you can determine that on your own, how long you want that to be. I like to come out here a good ways and say, well, that looks like about 2 pi. And that's going to be our wavelength. Okay, so from start to finish, since I'm starting at the origin, which is 0, if I go to 2 pi, that'll be a distance of 2 pi. Okay, so do you understand the wavelength is the distance that it's going to take to complete one cycle? Now, step number 4, I need 4 spaces, okay? I've got one big space, so I'm going to cut that in half. And if you want to label that, what is half of 2 pi? Pi. And then I'm going to cut that in half again. And so if I cut that in half, that would be pi over 2. Does that make sense? If this is a pi, then this would be half of a pi. And then I'm going to cut this guy in half, okay? So if I count by halves, that is 1, 2, 3 halves. So that'll be 3 pi over 2. Kind of important to know how to label those. Okay, so that takes care of our 4 spaces. Step number 5 is lay out your points. Now, since we're starting at the origin, we can either go up first or we can go down first. And what's going to determine whether you make the hill or the valley first is the original value of A. Okay, so since our original 2, before we took the absolute value, since that was positive, that means that we're going to go up first. So we're going up direction first. And the amplitude is the height of the wave. So at this first hash mark, we're going to be up at 2. Remember I said the reason you need your 4 spaces is because the hash marks are where your dots go. So I'm going to go up to 2. That's going to be as high as this wave can go. So at the next hash mark, I'm going to return to the x-axis. At the next hash mark, we're going to be down at -2. And that is as low as this wave can go. So then the next place to go is back up. Okay, so I don't know if you noticed, but you can see that the domain is all real numbers, which means that this graph is going to make a wave, and it's going to wave forever in both directions. This wave will continue to go back and forth between 2 and -2 forever in both directions. That's the domain. And notice that the wave is going to bounce back and forth between -2 and 2 for y values, the range of the y's. And this graph will never go below -2 and it will never go above +2. So that's how we get our range from negative amplitude to amplitude. And last but not least, we have step number 6, connect the dots. And we have our wave. That is graphed. That is 1 period. If it said to graph 2 periods, I would just continue in the positive x direction, lay out 4 more spaces, and continue to lay out my points and connect the dots, okay? But that's 1 period of that wave. Now then, let's switch to a different color and do the next example, which is y equals cosine of 2x. And here we can see that the lead coefficient is, which is a, is 1. And the absolute value of 1 is 1. So our amplitude for this graph is going to be 1. And the period is going to be 2 pi divided by b. And the b is the coefficient of x, which is 2. And these 2's will cancel. So that means that my period for this wave is going to be pi. I've got an amplitude of 1 unit and a period of pi units, okay? And so then we can go back to the 6-step process of graphing. Now, for our starting point, since this is a cosine function, we're going to start at a. And the a value was +1. And remember I said that that starting point is going to be on the y-axis. So on the y-axis, we're going to come up here to 1 and put a dot. That is our starting point for cosine on the y-axis at a, at 1. Step number 2, phase shift. We don't have one. Step number 3, wavelength is the period. So again, I'm going to come out here some distance, and I'm going to say, well, that looks like about pi. And this is where I'm going to throw in another fact, fun fact. You always finish where you start. So if I start at a height of 1, I'm going to finish at a height of 1. You finish where you start, okay? And so if I were to connect the dots here in the middle, that would give me the period, which is the wavelength, which is pi. Okay, step number 4, I need 4 spaces. So I'm going to cut this in half. Half of pi is, well, half of pi, pi over 2. And then if I cut that in half again, what is half of a half? Well, that's a fourth. And so then if I cut this in half, I know that that's going to be 3/4, because these spaces are all now a fourth. 1/4, 2/4, 3/4, 4/4 is a whole pi. So that's how you can label those. Not completely necessary, but it is nice to know how to get those. And now I'm going to get rid of those so I can connect the dots here, okay? So step number 5, lay out your points. At the first hash mark, I'm going to go to the x-axis. The reason is because I started out at the hilltop, and the only way I can go from the hilltop is down. So we're going down to the x-axis. At the next hash mark, we're going to bottom out at -1. That is as low as I can go, so then I've got to head back up to the x-axis and then back up to 1. And then we can connect the dots, okay? Like so. And we get a nice, well, somewhat smooth wave. Now you're going to notice that the cosine wave looks like one big valley, and the sine wave looks like a hill and a valley. Okay, these waves are actually the same. And let me illustrate how that can be, okay? If I were to continue my sine wave one more space, look at this slice here. Look at that compared to the cosine. Doesn't that look the same? But then if I take my cosine wave and continue it one more space, look at this slice right here. Doesn't that look like a sine wave now? So these waves may look a little different, but it's because you're taking a different slice of the wave, okay? They're really both what we call sinusoidal, and I'm going to make a note of that up here because that's kind of important. Okay, that is a fancy word. Sinusoidal, it means functions that make a wave. And there's only two. Sine and cosine are the only two that make a wave. And they're called the sinusoidal functions, okay? As a matter of fact, again, since these make a wave, they're going to be the only trig functions that have an amplitude. Because amplitude means how high does it go and how low does it go. And on these waves, you do have a maximum point and a minimum point, okay? Now, for the third and final example, and we'll do him in blue, I guess. Y equals negative 3 cosine of 3x. If I want the amplitude, I'm going to take the absolute value of the number in front. And so here our amplitude would be 3. And the period would be 2 pi over b. And in this case, b is 3. And that is not going to simplify. So we're going to have to leave that 2 pi over 3. And our amplitude is 3. Now, in order to sketch the graph, following the 6-step process, the starting point, since this is a cosine, is going to start at the value of a. Cosine starts at the number in front. So we're going to go to negative 3 on the y-axis, and we're going to put a point. That's the starting point. Step number 2, phase shift. We don't have one. Step number 3, wavelength, which is the period. And so I'm going to come out here a distance, and I'm going to call that 2 pi over 3. Okay, since I'm starting on the y-axis, I can simply come over to a certain distance and say, well, that's 2 pi over 3, and then that'll represent my wavelength, my period. Oh, and did you remember I said you always finish where you start? So I'm going to finish at negative 3, okay? That is step number 3, wavelength. Step number 4, 4 spaces. I'm going to cut that in half. What is half of 2 pi over 3? Well, that is pi over 3. Half of 2 pi over 3 is just 1 pi over 3. Does that make sense? Pi over 3 and pi over 3, 2 pi over 3. And then if I cut that in half again, what is half of pi over 3? Well, that would be pi over 6. Half of a third is a sixth. And so now I know that each one of these little spaces is a sixth, okay? So if I want to count, that would be 1/6. Wait a second. 1/6, 2/6 reduces to pi over 3. And then this would be 3/6. 3/6, which would be pi over 2. And this is where you really need to be good with fractions. You need to make sure that you know how to count by sixths and how to reduce fractions, okay? Would be super nice. And if you need some help with that, feel free to leave that in the comment section below that you don't really fully understand that, or you can text me and we can explain that in more detail, okay? So now that we know what those are going to be labeled, we're going to go to step number 5, which is lay out your points. Notice I'm starting at -3, so I'm going to go up to the x-axis, and then I'm going to max out at +3, and then I have to head back down to the x-axis and then bottom out. And then step number 6, connect the dots. We're going to connect the dots just like so. And again, I'm going to illustrate something here that I've not pointed out yet. Okay, did you notice that from the midline, this distance and this distance, okay? that is your amplitude. That's what amplitude means. It means how high is the highest point from the midline, how low is the lowest point from the midline. That's your amplitude, okay? And from start to finish, this distance here has got to be your period, the length that it takes to make one complete cycle. All right, and I would go ahead and go through the domain, but the domain is the same for all of these. The domain is going to be all real numbers, remember, because it makes the wave infinitely far in both directions. I guess we could do the range for each one of these if you want to. So for problem number 1, the range would be everything from -2 to 2. Do you see that? Because the graph is contained between those two values. Here the range would be -1 to 1. Again, because the graph is contained between -1 and 1. And for the last one, the range would be -3 to 3. And did you notice that I used brackets on every one of those? The brackets are necessary because that means that that value is included. And since we do actually get to reach 3 and -3, those are points that are included, then you use brackets for those. Okay, so the last thing we need to talk about then in this section is doing the reverse. If you're given a graph, can you get the equation? And the answer is yes. Turns out that it's not that hard. Here we go. For our first example here, we're going to call this example 1. The first step, the first thing that you need to determine when you're going to write the equation from the graph, you need to determine, is it going to be a sine or a cosine function? And if you go back up here to our notes, remember that the starting point, whether it's at the origin or the A, will tell you, if you do this backwards, where it starts at will tell you whether it's a sine or a cosine. So our first example here starts and goes through the origin, so that's going to make this a sine. Our second example actually starts at 5. It does not go through the origin. And so if I'm trying to figure out if this is a sine or a cosine, this one would be a cosine because it doesn't start at the origin. Next, the amplitude, okay? The coefficient of the trig function comes from the amplitude, okay? So if we go back to this first example, we can see that this graph reaches a maximum height of 4, and it does go up to +4 first. So that means that this equation is going to start with y equals 4. The 4 would be positive because it goes up first, sine of, and then we would need to figure out the b value. So b is the only thing we would need to figure out to finish that. For problem number 2, this graph starts at +5, and so our lead coefficient will be +5, okay? If this graph would have started, say here, and gone up, something like that, if it would have started at -5, then our 5 down here would be minus. I hope that makes sense. Okay, so we've got y equals 5, +5, and this is a cosine. Whoops, forgot to switch back to black. Back in black. All right, here we go. 5 cosine, and we still need to figure out the b value. All right, so how do I figure out b? Well, again, if we scroll up, whoops, come on. There we go. If we scroll up, we can see that b is part of the period. And remember, the period is the wavelength. So if I know the wavelength, if I know the distance that it takes to complete one cycle, I'll know the period. Once I know the period, I can calculate B. All right, so let's take a look at this. From start to finish, from one complete cycle, notice that these hash marks are counting by 2 pi. So then this hash mark would be 4 pi. You've got your 6 pi, so that makes this hash mark 8 pi, and that's your wavelength, which is the period. So we know that the period is equal to 2 pi over b. That is the formula, but our period is 2 pi. So we're going to say 8 pi equals 2 pi over b, plugging in the 8 pi for the period. And at this point, I can now solve for b. Okay, so we're going to make this 8 pi a fraction so that we can cross multiply. And that's going to give me 8 pi times b equals 2 pi. I can then divide both sides by 8 pi. And that will tell me that b needs to be 8 over 2 because the pi's cancel, but 8 over 2 reduces to a fourth. Okay, so then I can get my final answer. The equation that produces this graph is y equals 4 sine of 1/4 x. And that would be my final answer for that equation. Now let's do it for this other wave just for fun. Okay, so we've got our, in this graph, we've got our wavelength from peak to peak. This is the period, and it does that in a distance of 8, because if we start at 0 and go this far, that is a distance of 8. So that is our period, and the period formula is 2 pi over b, and then I can solve for b. So I'm going to make that a fraction, cross multiply, 8b equals 2 pi, divide both sides by, having trouble making my, there we go. Let's see here, divide both sides by 8, 8's cancel, and that's going to tell us that b is, now 2, again, 2/8 reduces to 1/4, and the pi is still there. So here that tells us that our b value is pi over 4. And so our final answer for this wave would be y equals 5 cosine of pi over 4x. That would be our final answer for that. All right, so then the only thing else I can think of to mention here would be that DESMOS is a great tool to help check this work, okay? And if you've not watched my other videos, I'm going to bring up a DESMOS window and show you what I'm talking about. So the website is desmos.com, DESMOS. You click the graphing calculator, and it's going to bring up your graph, and then over here is where you can input your equation, okay? So if I minimize this, slide this over, there we go, just far enough so that I can see this last example we did. And let's actually, I thought I could slide him over. All right, let's go back to Desmos. And let's type in this answer we got and see if it comes close to producing this graph here. So we can say y equals 5 cos cosine parentheses, and then to get the pi symbol, you can type the letters pi, hit the divided by on the keyboard for the fraction, and then move over and put your X. And then if you want to hit enter, you can, and you could do another wave if you want to, but we're checking this wave, okay? So if I click on this graph, look at that. To move it, I just click and drag. And if I want some of these critical points, I can just click on the graph, okay? So see that we're up at 0 and 5. And again, let me recenter that now that I've got that typed in. So we're up at 0 and 5 on the y-axis. 2 and 0 corresponds to this x-intercept. 4 is at -5. That's the low point. 6, we're back at the x-axis. And then at 8 there, we're back at the hilltop. So again, DESMOS it's just a tool. It's a tool you can use to put in your equation and then check your graph. And it's also handy to find these critical points here. Super easy. And that's going to do it for this particular lesson. Okay, so if you have any questions or comments about anything that I've discussed in this lesson, feel free to put those in the comment section below, or you can text me. And thanks for watching.